Oh, you see that? Okay. So welcome. Today I'll be producing I'll be trying to see two gases that when you mix together will spontaneously ignite. We want to see the oxidizing power of the halogens. You know, halogens are powerful oxidizing agents such that they can spontaneously ignite some gases. Some gases spontaneously ignite in some of the halogens, like chlorine, fluorine. They are very, very reactive and highly electronegative. So, and the two gases will be, I'll be mixing chlorine gas and acetylene gas, that is ethyne gas. The other one is colorless, but chlorine is greenish yellow. So, in real sense, I don't know if I'm really sure I'll do this experiment because it's a kind of, it's dangerous, but the precautions is that I have my eye goggle, you know. So over here, I have what will produce the chlorine. Here, I'm going to get the acetylene gas. So over here is my calcium carbide, as small as it is. So what I will do is calcium carbide reacts with water to release ethyne. So I'll put the calcium carbide here, and then I start producing my chlorine here. So this little space is where the two gases will meet. We might experience little explosion when the two gases ignite, and then we will have a residue of black carbon because the chlorine will definitely oxidize the ethyne to carbon. Remember, the removal of hydrogen is oxidation. So the chlorine will powerfully remove the hydrogen attached to the ethyne, which is C2H2, forming HCl, fumes of HCl. So this reaction, I don't even know if I'm really ready to do it, but I don't know if I'm going to do it, but let me try. Let me try whatever that comes out. But safety first. Everywhere this is open place, and again, you see there. This is another thing that will give me courage to do this, just in case if anything goes wrong. I got my fire extinguisher, but I know nothing will go wrong. Actually, not that. So if there is anything, so you play safe, and then you protect yourself. So let me keep it here just in case. And then I distanced the regions where the gases are produced. Here I separated it just in case. Oh, I could have called someone to put this and I'll do this. But let me take this risk alone. Let's see what happens, okay? So what goes first? Inside here is KMNO4. Here is my concentrated HCl, which will generate the chlorine gas. And then, so over here is my calcium carbide. I want to use another precaution is that since I'm afraid of this reaction, what I'm going to do is that I'll use very small amount to know what will actually happen. So these things, they might look small, but I tell you what, I will not underrate the ability. I'm looking at two sizes. This one looks, maybe it looks too much. I sure because of fear, let me manage this small one. So if it didn't work for the small one, I would not go for the higher one. So I wouldn't know which one will I go for first. Should I go for chlorine? Should I go for ethyne? Okay. Let me open this well just to get everything ready. Cameraman, how far? Do you think I'm ready to do this? Eh? Okay. Let's see. No problem. Don't mind me. That's the life of a scientist, whatever goes. Okay. I'm putting this. Let me. So the gas have started. So I'll come over here and try to generate. Okay. You see? I used a very small quantity. See the sparks? Oh my God, you see that? So I think I played safe. Okay, let it continue, no problem. So because this one did not, you see that? Okay, who's gonna take the second risk? Imagine how small. You see that? That's not sodium. That's just two gases. Eh? Doing this mighty work. I'm gonna take this risk. What will happen? Are you ready for the fire extinguisher? Oh! Oh, you see the black suits? This is very interesting. That black suit of carbon, I guess I'm going to increase the chlorine. Okay. Wow. That's amazing. Okay. Oh, you see that? I said we might see explosion. So we are in the mission of anything can happen. Okay. Where is the carbide? Oh my God! You see that? This is funny. When I get close, it will act. Stop this action. Cameraman, I hope you are not shaking. So, final. What? Damn, get away. But up here, the gas might still mix up. Oh. I know that dangerous thing. Okay, yeah. Done. There is no way. The distance is far. And the concentrations are less. Even when they meet on the air, everything is safe. So, thank you for watching. You can actually cause spontaneous ignition of some gases under halogens. So this proves that halogens are actually powerful oxidizing agents. I hope your hands were not shaking. So the most so the most powerful oxidizing agent should be fluorine, but over here this is chlorine. So most of them that is dealing with chlorine, you should be very, very careful. That means your domestic bleach can do this. If you add HCl to it, if you add any acid to it and add calcium carbide in water, you will likely experience what just happened here. And over here is black suits of what? Carbon, and we'll see steamy fumes of HCl. Let me check if the marker is working. So the equation of the reaction, sometimes the gases will still continue, sometimes. So we have C2H2 plus chlorine gas to give us carbon plus HCl. So definitely chlorine has stripped hydrogen out of the carbon, leaving behind just black carbon. So over here is black carbon. So balance the equation as usual. There should be 2 here. And then there should be 2 here also. That makes the equation balanced. Remember, this is the chlorine gas liberated. Remember, the reaction that happens in this water is calcium carbide versus water to liberate what? Ethyne. So thanks for watching. Play safe. Don't try this unless you take the precautions that I showed you here.